Hello everybody, welcome to EngiNepal next video. This video is basically based on the nodal analysis method. Uh, First, looking at the question, we can easily understand that there is a 12 volt voltage source between the uh, node A and node C. This means that the node A and C forms a supernode. Okay, uh, let's start the solution. Here, node A and C forms a supernode. Therefore, the supernode gives an equation of the voltage. Therefore, here we can see from the figure voltage A and voltage B. Between the voltage A and voltage B, there is a 12 volt voltage source, and we can write VA minus VC equals to 12. This gives the equation number 1, and while writing the equation, we can form the equation in a simpler manner. That is, the positive side of the battery is directing to the voltage A, VA side. So we can write the VA first and then VC followed by a minus sign, as in the equation 1, VA minus VC equals to 12. I think you understand this. Secondly, write the equation for the supernode A and supernode C, and forming the outgoing current as shown by the arrow. Now, using KCL at supernode A and C, we get that VA minus VB divided by 2 plus VA by 5 minus 5 plus VC by 2.5 minus 3, and there is a plus 8 ampere current moving towards the VV equals to 0. Here, while writing the supernode equation, we write the equation for the node A and node C at the same line. This forms the equation 7 by 10 VA minus 1 by 2 VB plus 1 by 2.5 VC equals to 0. This is equation number 2. Now finally, we write the equation for node B using KCL at node B. We get here in the node B, write the KCL, we get VB by 5 plus VB minus VA by 2 minus 8 equals to 0. Okay. Simplifying, we get 1 by 2 VA, writing VA first, 7 by 10 VV equals to 8, and this will be the question number 3. Solving equation 1, 2 and 3. There are the 3 variables and there are the 3 equations. So this will give the value of VA, VB and VC. So in solving we get VA equals to 14.15 volt. Similarly VB equals to 21.54 volt, and finally VC equals to 2.15 volt. I think there is one thing remaining in the question. We found the VA, VB and VC, and it also says to determine the current flowing through 2.5 ohm resistor. The 2.5 ohm resistor is here shown in the figure. 2.5 ohm resistor is located here, and the current to the 2.5 ohm, let it be denoted by I 2.5 ohm equals, it is given by VC divided by 2.5, VC divided by 2.5. This gives VC equals to 2.15 divided by 2.5. This will give, let's solve it. 2.15 divided by 2.5 gives 0.86. This will give the current as 0.86 ampere. This is the final answer. I think you got the solution and hope you understand. If there is any problem while solving this kind of numericals, you can ask me through the any means, or you can comment it down if you want the solution for that specific problem. Okay, thank you.